So here to talk through the skyscraper sum puzzle by Ashish Kumar with a New Year's theme for the rising of 2022. The rising refers to how we're going to have to add up to these values. A thing I do in some skyscrapers is often flip that on its head and think about what is hidden, so subtract from these values. 1 through 7 adds up to 28, so the maximum sum in a row like this is 28. So a sum of 20 is hiding 8 in the buildings that aren't seen. A sum of 22 is hiding 6 in the buildings that aren't seen. If I start with that idea of 20, I have to hide 8 from it. I can never hide the building of size 7, but I could hide 2 and 6. I could hide 3 and 5. I could hide 1, 2, and 5. I could hide 1, 3, and 4. Those are the only options for it. And across those, one of the things it's useful to think about is what are the first buildings going to be used. So if 2 and 6 or 3 and 5 are hidden, the first building seen will always have to be a 1. If 1, 2, and 5 is hidden, the first building size could be a 3. If 1, 3, and 4 is hidden, the first building size could be a 2. There's actually no way a 20 can start from a 4 building being the one that's there. 4, 5, 6, 7 gets you to 22. You can't hide 1, 2, and 3 to get to 6, as well as another 2 to get to 8. So this is a pretty natural constraint. You can do something similar for a clue like 22 if we actually cared to go through those spaces. So 22 is missing just the building of size 6. It could be missing buildings of size 2 and 4 together. That would still also start from 1. It could be missing 1 with 5, which started as a 2. It could be missing 1, 2, and 3 all together, which started as a 4. And so you can't start a 22 with a 3 clue, but you can start with a 1, a 2, or a 4 clue. So we can put some notes like this in the grid. And with what we started with this 1, 2, 3 constraint, you can actually also remove the 3 from that one cell. Notice that that is a triple and forces this 22 over here to have to be a 4. This is going to be a big building, so this cell, this cell, and this cell will all be hidden. These will have to add up to 8. So 4, 1, and 3 is how that works. This must be a 2, plus a 5, plus a 6, plus a 7 to get to 22. You can actually cancel value down here. So pretty good start. Some different ways to now work, but they're all going to take sort of the progress you made in this row and now turn it on vertically. And recognize when you put a big digit but not a 7 at the end of the grid, this will always be a hidden cell. So this 6 isn't seen because the 7's somewhere down below. And if 6 is missing, 6 is going to have to be part of the total sum of 7 that's missing from those 21 clues. So 6 and 1 are missing here. This will start with a 2 by necessity, and then I'm going to turn on the border clue to just do some of my preferred notation. I will have to see the 3, I'll have to see the 4, I'll have to see the 5, I'll have to see the 7, and in any of these 5 cells is where that 1 goes, but it'll be hidden wherever it goes. So 2 plus 3 plus 4 plus 5 plus 7 is 21. So I've got a good notation for this clue fully in the column. Do something like that for these other groups as well. I think this 22 on the far right is a good place to start. We've got a 2 in this clue, which means the digit 1 is hidden from it. And again, it's missing a total sum of 6. So a 1, 2, 3 is not an option when the 2 is seen. The only things that do work are 1 and 5. So 1 and 5 are hidden from this clue. 1 can be anywhere in the column, that's okay. But the digit 5 is going to be pretty tricky to hide. It's going to have to be after the 6 or the 7. So let's just think about the kind of values coming down. And these aren't exactly yet forced, but there's sort of a 3, and then a 4, and then a 6, and then somewhere a 7. But this 6 has tension around this 22 because it can't be right in front of a 22. We just had that from some of our prior notes. So the actual first space a 6 can go is right here. And again, I said the 6 is before seeing the 7. It's also before we'd see the 5. So this will have to have a 5, 7 pair in the space. The 1 is somewhere up here near this 3 or 4. This is a 1, 4 cells we had before. So this is a way this breaks out. Placing the 6 helps us a lot and gets us some headway for this whole column. Some other things we can do from this point. One is actually look at this row coming across. A 2 here means it's not at the start. It also means that 2 is hidden. And again, we're hiding 6 in this whole space. So 1, 2, 3 is hidden, or 2, 4 is hidden, but we don't hide a 5. So 7 is here, 5 is here. We have limited spots where the 6 can go because we don't want to be hiding lots of digits behind it. So I'm pretty sure we can't put a 6 any sooner than those cells. We don't yet know if the 4 is the first thing hidden, but it looks like there are some constraints working out here. And actually this first cell is one that's curious because it is going to be interacting with this clue up above. This is, again, a cell because it's not a 7 that must be hidden. And we talked in the 20 clue that there were a couple options that were hiding the digit 1, but there's only one option that was hiding the digit 4. And when you hide the digit 4 to get to a sum of 8, you also hide 1 and 3 together. So if 4 is down here, we also have to hide 1 and 3. Well, that causes an issue. 1 and 3 is seen in the first building in this whole sum. So 4 is quickly eliminated. If I put a 4 in here, there's no way I get to a 20 sum in that column. So this is a 1, this is a 3, and this is a 1. And what that means is now with this start in this row being a 1, I must see a 3 and then a 5 in one of these cells and then a 6. I have to hide the 4, so a 3 must come first, and I actually put the 5 before I put in the 4. So this looks like this. And now our friend 4 rears its head again. We just talked about how a 4 can't be 4 of 20 if it sees a 1 or a 3. Look at the cell. If this is a 4, again, we'd have to hide 1 and 3 in the rest of the column, but it's already seeing this 1. So this is a 6 here, this is a 4 here. If this is a 6 being hidden from this 20, the other digit hidden from that 20 is the digit 2. 2 will have to come after the next value, so this will be 3. Somewhere there'll be a 4 being hidden, but we have a 4 and a 5. Oops, sorry. 4 and a 5 and a 7 to make 1 plus 3 plus 4 plus 5 plus 7 equals 20. This 3 interacts with this 3, 4, puts in this 1. This 4 pushes this 4 up, it pushes this 4 down, and this 3 down. So some pretty quick progress there. You can eliminate the 1 from this cell. We have a 2 or 4 option. That still looks reasonable for the space, but we now know that 2, 5 are missing from this column. So this is a case where, again, the 5 has to be hidden, and it has to be hidden behind the 6 and maybe also behind the 7. So let's think about where can a 6 go in this column. And a first thing to note is with a 6 over here, a 6 can't be in this cell, and if a 6 were here, the 6 will also be hidden. So 6 can only be in one of those two cells. This has to see a 4 before it sees that 6, and it's going to see a 7 afterwards. This looks okay. This 5 has to be hidden after the 6, so it can be in one of those cells. Again, the 7 and any of these all look okay, so this is an okay start. Notice that this 5 and this 5 share these rows, so this will have to be 5 and 7 coming up here. Puts in this one. Another thing, though, to note is we're building out this column, and we've seen this before. A clue at the end of a row or column is hidden from the rest of it. And this 22, what is hidden from it? 1, 2, and 3 are hidden from it. So the only values I can put in the cell is either a 2, which would be hidden, the 1 and 3 which are already there, so those values. Or I could put a 7 here, but if I put a 6 in the cell, or if I put a 5 in the cell, it would become hidden from this 22 that has to see 4, 5, 6, 7 going across. So actually, having marked these notes in, there's a stronger thing I can say is the 5 has to be dodging the cell, the 6 has to be dodging the cell. And so that moves these around. It actually moves this 5 also then up. This is a 2, 7 in some order. Either will work out. We do, though, with this 4, 5, have to have a 6 before a 7 to work for this space. Once this is put as a 4 in front of this 22, this has to be 4, 5, 6, and that actually puts this 6 and the 7 in quite quickly. Puts in this 2, that's going to force a 2 here and a 7 here. We have 1, 4, 6 left in this row, and the only space left for that last 6 is here. 1, 4 to go with a 4 up above. These cancel. 2 and 7 for this column. This is the last space for a 7, puts in a 3. 2 and 3 for this space with a 2 already in the grid. 3 here, 1 here, 2 here. Finish the puzzle and all the sums work out. So pretty interesting workout, but a lot of the things to key into are really the first rows, first columns, last columns, cells like this that you don't want to hide. Definitely the very start of the puzzle was seeing how 1, 2, 3's force a 4 here, but I think the coolest deduction we ran into was how in this bottom row, the digit 4 can't be hidden from these two cells that have to see a 1 or 3 because the only missing set with a 4 in it is 1 and 3 and 4 together. So fair amount of different things here. Obviously, if you're on paper, you could write better notes about the missing sums for these 20s, 21s, and 22s, but felt they were minimal enough we could just talk through them and keep them in mind while we were working through the grid. So thanks, Ashish, for this great, challenging skyscrapers puzzle. Thanks you to watching the video, and we look forward to seeing you again soon.